Okay, this video is going to go over lesson 1.1. We are going to be covering linear regression and piecewise graphs. Starting off with a little bit of vocabulary, the first word is scatter plot, and we kind of talked about that a little bit in our warm-up day 1. And scatter plot is just going to be points or data plotted on a graph. And if you want to add a little bit picture, when we do our scatter plot, it's just going to be an L graph, our positive X and Y axis, and then some points. Next, we have correlation, and correlation is a relation. Oh, sorry, I'm writing way crooked. A relation between two variables. Then we have our regression equation, and our regression equation is going to be an equation that best fits the data. And regression equations can be written by hand. That does take a little bit more time and practice. This chapter, we are going to go over how to do it using our calculator though. So our calculator is going to do all of that work for us, and it'll save you some time instead of doing it by hand. Okay. Next, we have our correlation coefficient, and this is going to be represented by the variable r. Our calculator is going to calculate this for us, and we use this to determine if the correlation is going to be positive or negative. And we also use this to determine if it is a strong or weak correlation. Strong means the line is going to fit the data very closely. So the points on our scatter plot are all going to be very close to that line. And then weak means the points are going to be far away. So here is an example. So let's just do a bunch of plots like this. In this example, your R value would probably be something like negative 0.1. Because it's negative, that means our R, it would be a weak correlation, or sorry, a negative correlation. So because it's negative, it's a negative correlation. And then because it is far away from 1, that means it's going to be weak. So strong means it's close to 1 or negative 1. Weak means it's far away from 1. So 0.1, that's not close to 1. 0.7 or higher, that is going to be close to 1. An example of what it would look like with a positive strong correlation would be if we had a scatter plot like this, and the line goes through those points, and our R value here would probably be a 0.9. It's positive and strong because 0.9 is very close to 1 or negative 1. Okay, if you need to, you can pause it and finish writing your notes and drawing the pictures. But now we're going to move on to our first example. Okay, for example 1, you need to make sure you use all the steps that we went through on our warm-up day 1. So if you need to go back and look at page 3 to go through steps 1, 2, and 3, you can do that now. If you need to go back to the warm-up video number 1, you can do that, and it goes over all of those steps. Okay, So example 1, we're going to use the data to complete parts A through E. With this, we are going to sketch the scatter plot with labels and scales. So I'm going to go over exactly what is required. When we sketch a scatter plot, we need to label. So we're going to label our X and our Y axis. This one, we have our X values and our Y values. When you have a scatter plot, you should also give the graph a name. I normally just name it based off what the axes are titled by. So this one would be an XY, and we're looking for a correlation. So XY correlation. Then we're going to enter the data into our calculator. So grab your graphing calculator. You should have set it up using steps 1, 2, and 3 from our warm-up on page 3. We need to enter in our data. So you hit Stat, Edit, which is there. Now, I did an example before. So if you have information in here and you need to clear it out, you're going to go over the list name. You're going to hit Clear and then Enter. Oops. That'll clear out the entire list for you. You can clear it out one by one. That might take a while, so that is just a little bit of a shortcut. Okay. List 1 is going to be all of my X values. So this one we have 0, 5, 10. Oh my goodness, I cannot type the number 10. There we go. 15, 20, 25, and 30. Now, when you type them in, you want to make sure you go back and double check your list just to make sure you have all the numbers correct, because this can mess up your answers when you go to analyze the information. Okay, so then list 2 is going to be our Y values. We have 0, 15, 23, 38, 45, 60, and 65. Okay, now that we have all of our data entered, we hit zoom number 9, and that shows us our graph. So with your graph, once you have all the labels, we also need our max values for our X and our Y axis and our mins. Oops, sorry. So this one, our mins, we're just going to have it at 0. And we can use our data points to find our maxes for both of them. So this one had it in order. So our max X value is 30 and our max Y value is 65. And those both were on the same point. And then you are just going to sketch the graph the best you can. So you should have the same number of points that are on your picture, and it should look similar. So this one had 1, 2, 3, 4, 5, 6, 7 points. If I look at my graph, I have 1, 2, 3, 4, 5, 6, 7. There we go. Okay. Once you have that sketch, so you should have labels on the axes and the title, your max and your min, and then the points. So this one, the points were all very close together, almost in a line. So you shouldn't have any points up here or down here, because those don't look like the picture on your calculator. Okay, now this is where the new stuff is going to come in. Now we need to find the regression equation for the line of best fit. So the line of best fit, to do that, we are going to follow a few steps on our calculator. So the first thing you're going to do is you're going to hit the stat button again, which we've used before. This time though, instead of going to edit, we are going to go to calc. So you're going to hit the right arrow so you can go over where it says calc. Now in this chapter, all we are doing are linear regressions. They are going to be lines. So if you look at this list, you can see a few different numbers that have REG, which is short for regression, on your calculator. We want the one that says linear regression. So for that one, we can either do number 4 or we can do number 8. They just write their equation slightly different in each one. So this one, we're going to go with number 4. LIN regression. So that means linear regression, AX plus B. So we can hit number 4, or you can go down there to hit edit. Once you are on this page, so linear regression using list 1, list 2, we are going to hit the down arrows to go to calculate, and then hit enter on calculate. Now it's going to give us the information for an equation. So they give us the a value, which goes in front of x, and they give us the b value, which is our constant at the end. So for our answer, we're going to write y equals 2.1929. And for this, we're going to round to 4 decimal places. So whenever you need to round to 4 decimal places when possible. Don't forget the x, then plus our b value, 2.25. Now, don't clear this page yet, because our next question is, what is the correlation coefficient? And remember, the correlation coefficient is our r value. So if you look, they give us 2 r values. They gave us an r squared and then r. We just want the r value. And we're going to write down what that is, rounding to 4 decimal points again. So we have 0.9946. And the r value is typically going to be a long decimal. Then our next question, D, what does this mean about the correlation between x and y? And we're going to describe it as positive or negative and weak or strong. So with this, it's a positive number, so it means it's a positive correlation. And this number is close to 1. It's very close. It's 0.99. So that means it's going to be a strong correlation. This is a really strong one because it is very, very close to 1. But we just need to use the word strong to describe it. Once we have that information, we don't need this screen anymore, so you can hit clear if you need to. And next, they want us to predict the y value if x is 50. So now we're going to go back to our equation of best fit, and we're going to plug 50 in for x. So we have y equals 2.1929 times 50 plus 2.25. You can type that into your calculator, 2.1929. And then hit enter. And if you need to, still round to 4 decimal points, but for this one we don't. So our final answer is going to be 111.895. All right. So it is a lot of steps, but a question like this is going to be worth a lot. There's not going to be like 4 or 5 of these on the test. You just need to know how to do it once or twice probably. Okay, that was one example. We're going to do one more together. We're going to start this together, and then I'm going to have you work on part of it on your own. So for example 2, it says the table below gives us the number of FM radio stations from 1989 to 1995. Use the data to answer the following questions. Now this one has a disclaimer. It says, let X be the number of years from 1988. So we need to change this because we have years. We need to change it to our X values. From 1988, so we have 1989, that would be 1 year. 1990 would be 2, 3, 4, 5, 6, 7. So we are not going to use these years at all. We are just going to be using the 1 through 7 on the top. So now that we have our X and our Y values, we are going to make our scatter plot. So I would like you to pause the video, try to see if you can get your scatter plot and answer these questions on your own. Then you can hit play to check your answer. And if you're confident, you can skip ahead to the end once it has the answer. So we're going to edit the data. Remember to clear the list. You highlight it, hit clear, and then hit down or enter. So highlight the list, hit clear, and then enter. So we have 1, 2, 3, 4, 5, 6, and 7. All right, and then we have 4,269, 4,392, 4,570, 4,785, 4,971, 5,109, 5,730. Okay, once I have the data enter, I'm going to hit zoom number 9. And there is my graph. So this one has 1, 2, 3. 1, 2, 3. A little bit more of a space. 4, 5, 6. And this one's kind of up a little bit. 7. All right, so there is my sketch. I need to make sure I label it. So this one is years from 1988. This one is our FM radio station. I'm just going to put FM radio. And for my title, I'm going to put years / FM radio. If you want to write correlation, you can. That's not required. You just need to make sure it has a title. Okay, so then we need to find the regression equation for the line of best fit. So again, we go to Stat, over to Calc, and we want our linear regression. You could use 4 or 8. I'm going to go with 4. Once we're on this screen, we need to go to Calculate and hit Enter, and this will give us our linear regression. So for our equation, we will have y equals 222.0714x, and then plus our b value, which is 0.9647. Once we have that, then we need to write down our correlation coefficient. With that one, that is just our R value, and that is 0.9647. And what does this mean? So that coefficient is positive, so it's a positive correlation. And it's close to 1, it's a 0.9 again, so that means it is strong. If it's below a 0.7, that's when you can say it's a weak correlation. Next, predict the number of FM radio stations in the year 1999. Now remember, X is the number of years since 1988. So to figure out what our X value is, we're just going to subtract that 1988 from here. That'll give us the number of years. So you can do it by hand or use your calculator. And it should be 11. So our X value is going to be 11. That's what you're going to plug into your equation that we found in part B. Oops, there we go. So you're going to put y equals 222.0714 times 11 plus 0. Uh-oh, I wrote down the wrong b value. I am so sorry. Hopefully you caught that. Sorry, our b value is not this number. That was our R value. B is going to be 3,944. Okay, that's our equation. Once we have that, we plug that in to figure out what this is going to be. Perfect. 6,386.7854. And that would be our answer for part E. Okay, so if you need to pause this, you can. Here are the answers. You need to make sure you know how to do the steps on the calculator by yourself. I cannot help you with those on the test.